Hello, hello. Good morning, everyone. First session in the morning. I hope you didn't get hungover from yesterday party. Otherwise, there's plenty of coffee. So without further ado, this is Barry Riley from Black Tulip Technology, and he's going to be talking about the philosophy of architecture. So please help me welcome Barry.
Thank you. Thank you. It makes me very happy to see so many of you here. After 2 days at a tech conference, you've all decided we've had enough of technology. We want to go to the session on philosophy. And it's not just because we're a little bit tired after the party last night. So, I run a little company called Black Tulip Technology. I previously was a chief architect at a company where we didn't do a lot of Java. And since then, I've been working on a PhD within complexity science and software design. Now, part of a PhD involves writing a chapter that says, this is my philosophical position. This is how I look at the world. And me, with a background in mathematics and computer science, I had never had to do this kind of thing before. I had no clue what I was doing. So I went to the library, and I got kind of lost in there, in the philosophy department, and I emerged several years later where I was supposed to have a chapter with 7 pages, with around 300. And this was a bit of a journey, and that journey was expressed in some of the academic papers that I published as I started to move from computer science journals to philosophy journals, and eventually resulted in the release of a book last Thursday, The Architect's Paradox, which talks about the philosophical traps we find ourselves in as software engineers, without actually knowing that what's happening to us. So in this session, I'm going to talk about this journey that I've been on. What is philosophy in relation to architecture? My journey. What can your journey look like if you start to think about how you approach the design of software systems and conceptual models from a philosophical perspective rather than a computer science perspective, and how the future of software engineering could be defined or changed by these kinds of conversations. And the question that you're trying to answer whenever you start digging into these questions is always, why are we like this? Philosophy is about questioning your assumptions. It's about saying, what do I think? What do I believe? How did I get here? Where did these ideas come from? And this could be a bit of a shock for software engineers. It's a piece of research published almost 10 years ago, which is really illuminating on this subject, where they ask a large number of software engineers, in your last project, when you made architectural or structural decisions in your code, how did you do that? How did you arrive at that decision? What was behind that decision? And the overwhelming answer to this question is, we don't know. It felt good. I was right last time. I usually get away with this. I'm not quite sure. It's gut feeling. And this is the overwhelming majority of us experience this, that we make our technical decisions through gut feeling that we've built up over a long career. There's a sense of shame sometimes around this because we feel like we should be more logical and structured. And so this leads us to ask the question, what is architecture? What is software architecture? What is it that we're talking about? And this diagram here that you see on the slide represents the typical enterprise architecture way of thinking about an organization. We tend to say that an organization consists of these things at the highest level, C for capability. So we break an organization down into capabilities. Each capability in turn can be mapped to a number of business processes. And each business process can be mapped in turn to a number of software components. And what we get is this nice, clean diagram that looks like a circuit board. At this point, we have to ask ourselves, what would ever make us think that the chaos of a human organization or a business looks like a circuit board? Where would we get that idea? Maybe through our educations, through the way we've been taught to look at the world, through the lens of the computer. Real life is completely different than this circuit board representation of reality that architects draw. Real life is chaos. And if we have this blue character who wants to achieve something in a market, what they do is they stumble around, talking to different groups, working with different people, using different technologies, until one day, boom, they reach their market and they start to make money. And when you start to make money, then you need to buy stuff, you need to buy a whole bunch of computers, and then you need a whole bunch of software, and then you get architects. They turn up eventually. And what the architects do is they come in and they take all these white arrows and they map them to this kind of rigid circuit board-like structure. What then happens is that we realize that we missed a few things, and these green arrows represent the tensions and the unseen variables in a human network that we can't capture as architects. And this causes tension and it pulls on the network. And then what happens is that things appear on the periphery, new technologies, new actors. And all of a sudden, with those new technologies and new actors in combination with all this tension, there's a new way to reach this market. When this happens, we call it disruption on a business level. On a technology level, this causes that nice, clean, white arrow architecture to collapse because it can't keep up with the changes. The big example of this is Blockbuster. Many years ago in the United States, they hired DVD movies through brick and mortar stores. They had their white arrow architecture. They put a lot of work into making it efficient and optimal. They didn't see the green arrows, which was the kind of disappointment that their customers felt whenever they had to pay late fees very regularly. And that disappointment, along with the emergence of new technologies, and this little red guy, you all know who this is, Netflix appears and has an alternative. And then suddenly there's a new way to reach that market, which is easier, more profitable, more what the customers want. When Blockbuster decided that they needed to compete with this, they asked their enterprise architects, can we do this? And they said, yes, we can. We can transform our white arrow architecture and compete with this, but it's going to take us 18 months to do that. They didn't have 18 months. They were gone by the time that happened. This is the risk that our default view of the world brings to our business customers. This view of a human system as a circuit board, as something logical and ordered and structured the same way that the things that we've studied are, is quite dangerous to the businesses that we work with. So we need to start asking ourselves the question, what is architecture? What is it in theory? What is it in practice? And I like to use this example. Here we have a 14-year-old boy called Taylor, and his father is a physics professor. And he takes some of his father's physics textbooks and some contraband and builds a small nuclear reactor in his garage. Now, when a 14-year-old can take a textbook and endanger a small town with it, then we can rightfully say that theory and practice are pretty close to each other. One of the things we do in philosophy is called a thought experiment. And so as a first thought experiment, I'll invite you to think about what would have happened if Taylor's father hadn't been a physics professor, if he'd been an enterprise architect, and he brought a copy of his favorite enterprise architecture framework to that garage. What would Taylor have built? And the answer is, of course, nothing, or at very best, a small fire. Or, he may have been inspired to go out and do normal teenage things, which may have been the best thing all around for everyone. There is a gap between our theory and our practice. In theory, when you talk to architects, we'll say, hey, we work in a very structured way. And there's a scientific basis for what we do, because we studied computer science, and it has the word science in it. Which is also, that's based on math, and so we're analytic and we're rational in the way that we do our work. And if you've worked as a software architect for more than a few years, you'll know that this isn't true at all. Architecture in practice is usually pure panic. What is happening? Why is everything changing? Why is it changing so fast? Why is everyone telling me lies? But we do pretend that we're using theory. If a junior architect comes up to you and says, hey, I want to become a better architect, I want to learn, what should I read? What should I study? We'll give them a big pile of books. But we're not using the theory that's in those books, but we feel like we have to tell them something. And the symptom of this is that we struggle to articulate what we do, how we do it, how we make decisions. So basically, architecture is lying. And don't take my word for it. Let's go back to 1986 to this paper called A Rational Design Process, How and Why to Fake It. This is a serious academic paper written by a guy called David Parnas, one of the most important researchers in the history of software engineering. And what Parnas says is this: it's impossible to have a structured, repeatable, reliable way to design and deliver software structures. Every time you try to do it, it's chaos. You have to change your process. You have to invent new tools. You have to get rid of your old tools. It's chaos the entire time. This is the way our world is, he says. But in the second part of the article, he goes on to say that there's an enormous value in pretending to management that there is a structured, rational, ordered way of doing this. Just don't tell them about reality. Just pretend that it actually works the way everybody wants it to work. That's pretty scary, but it's also quite comforting, right? When you realize that we have permission to do this from one of the greats. So, what is it? What's the point of this conversation? The point is that there's a few problems with architecture that we need to solve. And those problems haven't been solved by any of the ideas that we've come up with so far. So let's dig into our underlying philosophy and see if there's a way we can change the way we look at the world rather than just adding patches. The first problem we have is something called the architect's paradox. It's a very important concept. The architect's paradox works like this. In order to invent computing machines, we had to have a complete focus on logic. Okay, so you go back to Turing, von Neumann, and what those guys were doing. The focus was purely on logic at the exclusion of everything else, and we became very, very good at pure logic. That same focus on pure logic will, by 1968, deliver something that we collectively call the software crisis. Why does nothing work? Why is it always late? Why is it always more expensive than what we thought it was going to be? The software crisis is a direct result of the same kind of thinking that we needed to get to the computer. And this is the paradox. The better we get at programming, the worse we get at dealing with complex business contexts and dealing with the world around us. Those problems appear in this guise. Time, change, and uncertainty are the three pillars that define the work of the architect. These are the things that make our work interesting and make the role of the architect necessary. We all know that an architecture that we sketch today, a static picture, usually in UML or sometimes in Archimate or something like that, will not be the same 6 months from now. And it will not be the same 12 months from now as architecture shifts over time along with the business context and the business around us. Why don't we deal with this? Why do we draw these static representations as if they're the truth? Well, why do they change? Why do they change? Or why are they different over time? They're different over time because the business context changes. Things change and move. Why do we ignore it? Why do we sweep it under the rug? Because we don't know what's going to change. Our business stakeholders don't know what's going to change. And so we pretend for the moment that we live in a static world. It makes life much, much easier for all of us. Another problem that turns up is this idea of the unit of software engineering. What is the unit of a software architecture? What's a software architecture made of? And this idea goes right back to ancient Greece. Where 2,500 years ago, a philosopher called Thales declared that the world and everything in it was made of water. Now, from our modern scientific perspective, that's a ridiculous idea, that everything is made of water. He was obviously wrong. But it wasn't his conclusion that was important. It was his instinct. His instinct was to boil everything down to one thing that we can all agree on. And once we've agreed on that one thing, that opens the doors to a scientific discipline where everyone's in agreement on this one paradigm and we can move forward with it. Other people came along, they said, you're wrong about it being water. It's actually all made of earth or wind or fire. eventually, not very long after, a philosopher called Democritus comes along and says everything is made of tiny, tiny little things called atoms. And that idea has held for 2,500 years. Physicists have this atom as their fundamental arche, or building block. Chemists have the molecule, biologists have the cell. This is an important step towards creating a real science. Software has been on a bit of a journey. We still haven't really landed this yet. We're still in our Greek phase of earth, fire, wind, water. And we've bounced around from the machine to the punch card, to the procedure, to the module, to the object. We bounce around every few years. There's a new arche that someone comes up with, like a microservice. Everyone gets excited. Everyone rushes off the cliff like the lemmings we are. And then we reboot. And this constant shifting in paradigms is a sign of something. And this guy, Kuhn, writes a book in 1962 called The Structure of Scientific Revolutions. And he says that you have an established paradigm in which everyone works. And what happens is the paradigm starts to fail. We start to find cases, we start to find examples where the theories and the ideas that make up the paradigm don't hold. They can't explain what's happening. And what happens eventually then is that the entire paradigm collapses and we get new thinking. This happens for us in software every few years. There's a new idea, a new arche. On a wider scale, in 1968, when they defined the software crisis, they decided that the solution to the software crisis was for us to become more like an engineering discipline, that we should copy the other grown-up engineers in the way that they acted. And a lot of the ideas in software engineering that we know and love, requirements engineering, risk management, all that waterfall kind of planning, was from that attempt to make software an engineering discipline. And this created a paradigm called which I call the engineering paradigm, which we've been in for a very long time. Now, the big thing that has shaken the engineering paradigm is the Agile movement, who said, hold on a minute, this is not working. And it's taken 25 years, but eventually we're going to see this engineering paradigm collapse and something new will emerge. All of these problems that I'm discussing are philosophical problems. You won't solve these by hacking or by waiting for a product from your favorite vendor. We need to do something different. So let's have a little bit of a look at philosophy and see, are there any clues here as to how we could solve these problems? The architect's paradox, where we try to solve and model and map business contexts using the same logic that you use to write computer code and develop computers, is an impulse. And the impulse is to hold the world still. And that's very appealing to us. If you're trying to design an object structure or a component structure that describes a business, you have to, at some point, hold it still to map to those objects, to those components. But this isn't just software engineers who do this. This has been a problem since ancient Greece. The ancient Greeks tried to hold the world still so they could map it and model it and get a grip on what's there. And we've just copied them. A very famous article that many of you may not have read, but it influences your thinking every single day as an architect, is an article called On Scientific Thought from 1974 by Edgar Dijkstra. And this article introduces the concept of the separation of concerns, which is incredibly important to us as software architects and engineers. The separation of concerns, you've probably all heard of it, is defined in this article as we focus on one thing at a time and we hold everything else still in order to map and model something. And this impulse comes from very far back in the past. In ancient Greece, there were two philosophers who are referred to as pre-Socratic philosophers. Parmenides, who is this guy in the fancy robes. In those fancy robes, he's obviously some kind of product manager. Because he has a little project plan here in his hand. And Parmenides says that reality is just one thing. The universe is one, and it's still, it is unchanging. And the only reason we think it's changing is because our tiny little minds are corrupted, can't cope with it. We think things are changing, but they're actually not. And if we just got a little bit smarter, like Parmenides, we would realize that everything is still. This is where the impulse comes from to hold everything still. Now, on the other hand, we have this guy here, Heraclitus, and Heraclitus looks like a senior software engineer. And Heraclitus says that the world is not still, it's not one thing. The world is crazy. It's in constant flux. Everything is moving, everything is changing all the time. Heraclitus is also the philosopher who says that the arche, the unit, the thing that everything is made of, is fire. Everything is on fire, everything is changing all the time. Definitely one of us, right? He has experienced those he's experienced those death marches. And Plato then, who is going to define Western philosophy for many people, most of us, chooses the way of Parmenides to say that everything is still, everything is one. We are disillusioned. We do not see properly. And this informs this default philosophy that we develop. And the question then, and we can ask of ourselves, is where do we come from? Why do we think the same way as these ancient Greeks? What's the roots of our thinking? And the roots of our thinking can be found in the thinking of these people on the slide. And most of these names should be familiar to you. Another three thinkers that probably aren't as familiar to you lie behind these thinkers and the way they look at things. And that is Frege, Russell, Wittgenstein. And these are three thinkers who take logic and put it at the very, very center of everything. Their unit of everything is not fire, earth, wind, or water. It is logic. Logic is the thing that defines the reality around us. They influence and work with von Neumann and Turing and influence the development of software architecture. And they have ideas like our language and our logic reflects the reality behind them. And that will lead to the development of ideas like requirements engineering, atomic requirements, all of those things. So these three thinkers, which very few of us have heard of, unless you have philosophy as a hobby, will go on to influence computer science for a very long time. All of these people have one thing in common, and that is a philosophical way of looking at the world that roughly can be called positivism, or logical positivism. This is the belief that we can uncover the laws that govern the universe just by running scientific experiments, and that the universe is clockwork, everything works in a mechanistic way, we can figure that out, we can reduce everything to models, and those models will help us understand and predict and control how reality works. And this is why, this underlying school of thought, this is why we represent organizations as circuit boards. This way of thinking gives us computers, so we shouldn't dismiss it. We wouldn't be here without this way of thinking, but it also makes it incredibly difficult for us to engage with complex business contexts. Okay. There is a different way of thinking. There are many different ways of thinking, but the one that I've chosen here just to juxtapose this is called interpretivism, which comes from the social sciences. Positivism says that there are laws that govern the universe, and we can uncover these laws by the scientific method, by experiment, observation, empirical methods. It believes that knowledge is external to us in the world, and we discover it through science. Interpretivists believe that there are many different views that can be taken of reality. There isn't just a law that governs everything, but our perspectives are important. It rejects the scientific method for social systems, and it believes that knowledge is transmitted through ideas and debate. Now, if you scratch the surface of a software engineer, you'll find that they believe in something that's very close to positivism, but they learn, as you're learning now, in a way that's very close to interpretivism, through listening to people speak, through debate, through ideas. And so we have this schism in us, which doesn't quite match up. And if you dig a little bit further, what you'll find is that there is a default philosophy that most of us in this industry share. We don't know that it's there, we don't know how it got there, but we all have a similar set of ideas about the world around us. The first idea is something called essentialism. Essentialism is the belief that everything that you look at around you contains an essence, something that makes it it. And what we try to do as software engineers very often is boil that thing down to its essence. So we'll say, what is a customer? What are the properties of customer? We try to find this brilliant, perfect customer object that will never break. Plato had an idea. This thinking comes from Plato. Plato said that there is a heavenly realm, not on earth, somewhere else, where there are these perfect forms, these perfect abstract objects. And all the objects on earth that we look at are simply crappy copies of this perfect object in this heavenly realm. So there's a heavenly version of a cat that describes what the perfect cat is, and every cat we see on earth is a crappy copy of that perfect cat. Now, when I tell developers this, they laugh, and they say, these Greeks, what weird ideas they had. Who would ever think of such a ridiculous way of thinking about the world? And then I ask them to consider the case of object-oriented programming, where we have this magical heavenly class that defines the perfect customer, and all these instances, slightly less perfect, of customer that are running in production. Object orientation is a pure distillation of these ideas. And things from TOGAF, like architectural building blocks and solution building blocks, are also the same impulse. Now, this search for essence of things gets very tiring when you have lots and lots of things. And when you have lots and lots of things, you start to consider the relationships between those things in a business context, for example. So you don't just have customers, you have customers and orders, you have different kinds of customers, and you have different kinds of products and all of these things. And what you start to do is draw lines between them. And as you draw lines between them, you start to believe that there's a structure behind these things. And a bunch of ideas from the 1930s emerge from a guy called Desfossard and Levi Strauss, and they say that there's structure in the world. There's structure in our language, there's structure in our societies. If you discover the structure, you'll come to knowledge about the thing. And this is something that pervades architectural thinking. It turns up in requirements engineering, where we believe that if you just get the requirements right, if you write them in the right way, if you catch the phrases in the right way, if you make them smart, then you will capture the structure of reality behind what your stakeholders are saying. That's the belief. And something like domain-driven design goes even harder on the question of language. It says that you can get to reality through language. You don't have to work very long in our industry to realize that this gives you a headache. It doesn't work the way that the belief says it's going to work. On top of these two ideas of essentialism and structuralism is the concept of causality, mechanism, and determinism. So we believe that systems are machines, social systems, businesses, we look at them the same way we look at machines. If A, then B. There's direct, efficient causality. And this leads to the idea that the world is mechanistic, that the world is a machine, and deterministic, so we can figure out what's going to happen in the future, and we can predict what's going to happen. And this has its roots in Descartes and Newton, going back several hundred years. This influences everything that we do. Added to this is the concept of cybernetics. Cybernetics is a bunch of ideas that emerges in the 1940s that treats human systems like mechanistic machines with feedback loops, like thermostats. And this reinforces this machine metaphor. All of this comes together for architects collectively as a set of models. We create a bunch of models, and those models are informed by these philosophical ideas. All of these ideas can be referred to as a single philosophy, which is called logical structuralism. It's in all of us to different degrees. We don't know how it got there. We don't know where it came from. I think computer science is a major culprit in this. This is the way we look at the world. What we do with this logical structuralism is we take reality and we cover it up with a whole bunch of models. This is what the architect does. And what we then start to do is we start to live through the models instead of living through the reality that that our software actually runs in. And this causes us an enormous amount of grief. A French philosopher called Baudrillard, which I can't pronounce, says that this is very common, that we live through a model instead of reality. And he analyzes American society and says they're living through the model presented to them on television rather than living through the reality. His book is very famous. You can see from this still This is the book that the movie, The Matrix, is based upon. And in the movie, at the start of the movie, when Neo goes to his bookshelf, he has a hollowed out book with some hidden illegal stuff. The book is actually Simulacra and Simulation by Baudrillard that describes this inability to engage with reality because we're engaging with a model of our own construction. Sometimes architects, when you build all of these models and you stop living through the reality of your users and your customers and your developers, you'll be accused of living in an ivory tower. It's a standard insult. It's not an ivory tower, it's the Matrix, and we built it ourselves. Now, when I tell developers this, they get really excited, and they think, oh, we're in the Matrix, I must be Neo, I must be Trinity. That's not true. You are the architect. And the architect looks a little bit like someone called Norbert Wiener, the guy who invented cybernetics, who made us think that machines and organizations were the same thing. You can tell he's an architect because he promises utopia in version 1.0. You can tell he's an architect because it doesn't happen. And you can tell he's an architect because instead of trying something different, he just adds patches. He says, okay, let's have an Oracle, let's have an Agent Smith, let's have a Neo, let's have a cycle. And he gets caught out by one of those green arrows. He gets caught out by an emotion, by the fact that Neo falls in love in this movie, causes his entire system to collapse. And that's very like us, right? We miss an emotion, we miss something in the social system. There's no place on that circuit board for love, or emotion, or humanness, so we map it out. And so, how do we get out of this? How do we escape this matrix? And the way to escape the matrix that I have found was, first of all, through the complexity sciences. And the complexity sciences is a scientific discipline that's dedicated to the study of flux and uncertainty. But there's a deeper philosophical thing going on, and it's called emergentism. And emergentism works like this. We have a bunch of stuff, things, and they all sit very close to each other, perhaps they're connected to each other. Now, the impulse of the software architect is to dive in and start talking about what are these things, what are their properties, how are they related to each other, what's the structure here, how does this machine work? So we can take as an example, these could be neurons. Put those neurons together, you have a brain. What happens when you get a brain? Well, something emerges, something that isn't there in the little building blocks. So you have all these little neurons close together. The thing that emerges is called Barry. And if you cut these little things up, you won't find any Barry in there. This Barry that emerges develops some bad habits. He likes sugary foods and beer. And when he eats lots and lots of those things, this impacts the neurons, and they start to not work as well. This makes Barry sad. So Barry drinks more beer, which affects the emergent system, and what we have now is a spinning circle of constant change and flux. Not only that, but we have an emergent system that cannot be grasped, cannot be mapped, cannot be broken down to small pieces. All of our ideas fall apart. A business is just like this. A business context that we have to build software for is an emergent system. These ideas are found in Spinoza, in Nietzsche, in Descartes, in many, many different areas of philosophy. Understanding this is crucial. The philosophies of stillness don't like to deal with this. They try to get around it in various different ways, like Descartes, who splits the mind and the body and says, look, let's just deal with the stuff we can deal with. But a number of other philosophers, Bergson, Deleuze, in the 20th century, start to formulate what I call philosophies of movement. Philosophies that allow us to engage with this emergent world that we, as software architects, live in. And the question here is, how do we gain knowledge? This traditional architect's way of gaining knowledge is to observe the thing, isolate the thing, map the properties of the thing, categorize the thing, run some scientific experiments. There's a different way found in the work of these philosophers. How do we gain knowledge? So let's say I've moved house. I have a new house. I've just arrived in a new area, and I'm going to go for a walk. So I pull up this map, on Apple Maps and I decide I'm going to go for this walk. Now, does this represent knowledge? Yes, this is a form of knowledge, but it's abstract knowledge. This abstract form of the map will apply all over the world, anywhere that Apple has mapped. Is it enough knowledge? No, not for an architect. The first time I take this walk, I'm very concerned about getting lost. So I have my phone with me, I'm not really paying attention, I'm looking for street signs, I'm making sure I'm in the right place, I'm making sure that I'm not going to get lost. The second time I take the walk, assuming I have a reasonably good sense of direction, I start to notice things that are different than the first time I took this walk. The first thing I notice on my second walk is that this particular patch of path here is shaded in the summer. And since we're all in Sweden today, everyone knows that this in the summer means mosquitoes. And that means that I am not going down that path. I'm going to find another way around. This is knowledge. This is necessary knowledge. You won't get this in an abstract map. I take another walk and I realize, as a foreigner in Sweden, that not all paths have gravel and sand laid out in the winter, and if you take the path that's over there, you'll end up in the water because it's very slippy. That is important knowledge. I take a walk in the summer in different circumstances, and I realize that if I leave the house at a certain time, I get to enjoy this view. Over time, I realize there are certain days where you just shouldn't take this walk at all. But what I do is, every time I take the walk, I'm repeating the same walk, but I'm noticing small differences. And the sum of those small differences is how we come to knowledge, according to Bergson and Deleuze. And this knowledge is what we need in order to understand a system and to start designing conceptual structures for it. Now, there's a huge problem we have in software architecture, and that problem is this. No architect delivers their architecture in exactly the same way. Every architect has their favorite set of tools that they use in order to get to an architecture. And the thing that makes it difficult to understand this world is that two architects with two completely different tool sets, two completely different stacks, can both succeed. And if you take any one particular architectural tool, you can say, does this tool work? If we look at all the successful projects in the world, what percentage of projects are using this particular tool, architectural tool? And the answer usually is like 1%, because everyone does things differently. So based on that, is this tool absolutely necessary to a successful architecture? And the answer has to be no, because 99% of successful projects don't use it. You can use this argument on every architectural tool. And when you get to the end of all the architectural tools, which will take a while, you'll realize that none of these tools is strictly necessary to deliver a successful software architecture. So everything we have is not necessary. That's a weird thing to think about. The thing that we do as architects is that we walk. We walk around the problem, and we walk around the problem repetitively many different times. And every time we walk around the problem, we look at it from a slightly different view, and we pick up a new piece of knowledge. It's like walking in a different season, walking in a different day, walking in different weather. And all the tools that we have as architects, what those tools do is they allow us to walk from a slightly different perspective. So requirements engineering and risk management and capability mapping and process mapping and value stream mapping and all of these things, what they actually deliver at the end of the day, the documents they deliver, isn't important. It's the walks they trigger. It's the way they force us to contemplate the system. And what this is then is a very important theory of architecture. This is how architecture actually works. This explains why we can all do things so wildly differently and still arrive at results. My consulting work is almost entirely about rescuing crashed projects. That's what I do. And every crash project that I've ever seen is the product of too few architectural walks. If you don't take enough walks and you don't repeat enough and you don't see those differences, then you are highly likely to experience problems in that project. And another concept that's incredibly important which I talked about here a few years ago at Jfokus, is the idea of criticality. Criticality is the ability of a system to withstand things that it hasn't been designed for. As an architect in a changing business environment, that's what we have to do, okay? If we just want to build static things, developers can do that without us. They don't need architecture for that. So an architect's job is to make sure that the system, the structure that we build, is going to survive as the business context shifts and moves. And the ability to survive something that shifts and moves is called criticality. And humans are critical. We can survive unexpected things. Our societies are critical. Our forests are critical. And this is what we need to aim for. So for a programmer, if you're a programmer, your goal is correctness. Your code should run correctly. That's what's drilled into us at university. When you're an architect, there's no way on earth you can be correct because there's simply too many trouser legs. There's too much that's going to happen. So the only thing that you can deliver as an architect is criticality. And this is two completely different things. And this requires a shift in how we think about what we do. And so what I've talked about here as we move towards this idea of walking rather than things, process instead of substance, movement instead of stillness, difference instead of essence, criticality instead of correctness. This means that becoming an architect, philosophically becoming a good architect, requires a huge philosophical shift. And those who survive in their careers and go on to become senior architects do this automatically over time. But it takes a long time and a lot of experience. In my earlier work and in the more pragmatic work that I've done, this book tells you exactly how to build an architecture in circumstances where you don't understand what's going on. I've embraced these ideas and I've come up with a unit of software architecture which I call the residue. And the residue is built specifically to capture time, change, and uncertainty across the life cycle of an architecture. This completely changes how we do architecture. It uses tools like random simulation and ideas from the complexity sciences to give us a completely different way of building architecture. And I was able to do this by diving into my philosophical assumptions and tearing them to shreds. And I'm just one architect. If all of us do this, if all of us investigate our philosophical roots, then we will, all of us, have the capacity to really understand our own architectural process and be able to articulate it much better. And what we should see is an absolute goldmine of architectural ideas emerging if the whole industry can take this conversation. And so, in conclusion, as a software architect, you already have a philosophy. You probably recognize some of the things I've talked about in the default philosophy. You probably thought, I do that, I think like that, I've seen that other people think like this. But you don't know what it is. And it's encapsulated in gut feeling, in reflective practice over many years. And it's often surrounded by a little bit of marketing, which you've been exposed to, some random ideas, some moonshots. Learning how to use philosophy to question this default philosophy is incredibly important. And to unplug from the matrix, we have to ask ourselves, am I suffering from the architect's paradox? Am I trying to address business contexts using rigid logical thinking, which belongs in the machine, not out with the people? If you become responsible for your own philosophy of architecture, expose yourself to some form of thinking outside of STEM, then you will be able to break out of this matrix. And once you control the architecture doesn't, or once you control the model doesn't control you. Now, a question I usually get from developers, especially junior developers at this point, is, what's the point in all this? What do I do with this? Is there a library I can download to help me do philosophy? And what I'm expecting you to do with this is to start to really try and understand your own thought processes. What you want to be able to get to as an architect is that when someone asks you, looks at your architecture, points at a little part of it and says, why are there 3 components here, not 2, not 4? you want to have a pretty solid answer for that. And you want to understand how you got there, why you got there, and what the thought process was for you to get there. Philosophy and the kind of ideas we've talked about today is how you're able to answer that question. And once you're able to do that, the work of architecture, the design of conceptual structure becomes incredibly easy. And so this means that we have to move forward reflectively, questioning our assumptions. And I've given you some tools to do that. That's not for everyone. You don't have to do this. You don't have to think about these things. You can think this is boring, pointless, or fluffy. The people who take this step will carry the next generation of architects forward with tools and ideas that are going to change how we think, because it is time for us to move away from the engineering paradigm and change how we think. And at the end of the day, the message is there is no spoon. These tools, these ideas, they all melt. You can make them melt. It's not the spoon that bends, it's you. You can find these ideas in these two books. The first one is a very pragmatic way of building software systems in conditions of complete uncertainty. The second book is more based on, it shows a history of philosophy and maps that history of philosophy to the history of software engineering, which it turns out there are some similarities. So that's everything from me. I'll be here for the rest of the day on balkongen at the Dataforening's booth. Well, for a few hours anyway, if anyone has any questions. Thank you.
Thank you, Barry. We have some minutes for questions. Anyone? Okay, so please don't forget to rate your session. You all know